Hi students, let us begin with topic number 4, that is radio receivers and television. In yesterday's lecture, we introduced the meaning of radio receiver. We studied how to proceed with this particular topic, that is plan of our lectures. Then we have studied the types of receivers, radio receivers obviously. Then we have studied the characteristics of a radio receiver. After that, we have studied the super heterodyne principle. Friends, we came to know that receiver is that part of the device used in the electronic communication that receives the radio frequency signal converted by means of an receiving antenna, processes it, especially demodulates it, and recover the original information necessary to be provided to the destination. Receiver is always tuned with the transmitted frequency. We studied that receivers are of two types. One is a TRF receiver, that is a tuned radio frequency receiver, and another one is super heterodyne receiver. Due to drawback of TRF receiver, that is, its bandwidth changes within the tuned range of frequency, to avoid that, super heterodyne receiver is widely used in practice. That works on super heterodyne principle, and the principle is that when it receives the two frequencies, say F1 and F2, both are going to beat with each other, and at the output 4 frequencies are generated. One is two original frequencies, second one is sum of their frequency, and last one is the difference of these two frequencies. And the difference of these two frequencies is called as intermediate frequency from the point of view of electromagnetic wave propagation. This IF is used for the further processing in the receiver. We studied the 4 good characteristics of receiver. One is the sensitivity, second one is selectivity, third one is fidelity, and fourth one is signal to noise ratio, which should be proper so that the receiver is going to perform the analysis of the received signal in a better way, and the signal is made available for the destination. Friends, in today's lecture, we are going to cover a type of super heterodyne receiver known as AM super heterodyne receiver. As it has the name that AM means amplitude modulated. This is the receiver which is used to demodulate the amplitude modulated signal, and that uses the principle of super heterodyne, and that recovers the original information from the amplitude modulated wave and provides to the destination. Such a receiver we can call it as it is AM super heterodyne receiver. This receiver has good sensitivity, better selectivity, fidelity is also good, and signal to noise ratio provides better rejection of the noise and receives the large amount of power. So all these properties which are required or which are to be treated as the receiver characteristics, all are being satisfied by means of this AM super heterodyne receiver. It operates in a wide range of frequency. That's, we can say, AM super heterodyne receiver satisfactorily operates on any frequency with constant selectivity, good sensitivity. If you look to the block diagram of AM super heterodyne receiver, it consists of a receiving antenna, RF amplifier, mixer, local oscillator, IF amplifier, detector, audio driver and audio power amplifier. Its output is given to the speaker. In generally, the signal transmitted by the transmitting antenna is interrupted by the receiving antenna. It converts electromagnetic radiation into RF signal. This receiving antenna is tuned to the incoming signal from the AM transmitter. It receives that particular frequency. RF amplifier has a very wide bandwidth so that it is capable to receive almost all the signal which is going to lie within that particular bandwidth. RF amplifier rejects unwanted signal and accepts only wanted signal for that. Its signal to noise ratio is also more so that it is capable to reject the noise, high frequency noise, and receives only the signal information. The gain of RF amplifier changes as per the strength of the signal received. If the signal received is weak, the gain of RF amplifier is automatically increased by means of an automatic gain control circuit. And if the signal is strong, the gain of RF amplifier is decreased. It makes use of several stages of the amplifier to achieve the required gain to the incoming signal. As a being, the signal received by the receiving antenna is weak, it should be amplified to the required level. So that signal contains the carrier wave modulating signal. Such a AM modulated wave, we have studied AM modulation in topic number 2. That signal, after being processed in RF amplifier, by obtaining the required gain, the signal is named as a FS and that is given to the mixer stage. Mixer, as the name it suggests, it mixes two signals. One is the signal from the output of the RF amplifier and second one is the signal from the local oscillator. Let that local oscillator frequency be FO. Both the signals are given to the mixer. Mixer makes use of non-linear devices along with the passive components, so that in the mixer the signal frequency received from the RF amplifier and also the frequency received from the local oscillator are going to beat with each other. After beating these two frequencies at the output of the mixer, 4 frequencies are going to be produced. One, signal frequency as it is, local oscillator frequency as it is, sum of both frequency and also the difference of both frequency. The local oscillator frequency is always kept greater than that of frequency of the incoming signal. Means one can change the local oscillator frequency as per depends upon input frequency it is received. The difference between local oscillator frequency and signal frequency obtained at the output of the mixer, it is called as intermediate frequency. The combination of RF amplifier, mixer, local oscillator, it is called as RF tuner. This section is used to tune the receiver to the incoming transmitter frequency. So IF output obtained contains almost all the signals along with the modulated carrier wave. This signal will be given as an input to the IF amplifier. This IF amplifier has only the bandwidth equal to the intermediate frequency coming out of the mixer. Here, the signal is again amplified to the required level. So, amplified signal is given to the detector. In detector, the demodulation process that takes place. As it is AM super heterodyne receiver, here envelope detector is suitably used, which we have studied again in topic number 2, which is the combination of a point contact diode and the resistance and capacitor connected in parallel with each other, and combination of it is connected to the diode. So that forms the envelope detector. We studied how the modulating signal is separated from the modulated wave. Here carrier wave is removed, only required information is provided further. This is given to the audio power amplifier. This audio power amplifier is driven by means of an audio driver amplifier. Audio driver amplifier does the job of driving the audio power amplifier. Here only the signal which is going to lie within the audio frequency range, it is amplified. It may be a push-pull power amplifier or it is a complementary symmetry power amplifier. So audio frequency amplified signal is given to the speaker. We know the role of speaker. Speaker converts the audio frequency electrical signal into acoustic sound signal. The local oscillator might be Hartley oscillator or Colpitts oscillator, or it might be a kind of a crystal oscillator that generates the frequency in a radio frequency range. The signal here is connected to the IF amplifier and RF amplifier just to control the gain of both the amplifier circuitry. Thus, in general, it tunes the incoming transmitted frequency, processes it by using the super heterodyne principle which is being obeyed in the tuner, and then it generates the acoustic audio frequency which is used for the listening purpose. So this is how we can describe the block diagramic aspect of the AM super heterodyne receiver. Let us see its details, technical aspects and all other things. From this particular figure we can say the RF amplifier is tuned to the required incoming frequency. The output of RF amplifier is combined with the local oscillator frequency at a mixer stage and converted into low fixed frequency IF that contains some same modulation as the original carrier. A fixed IF is maintained by tuning the capacitor of local oscillator with the RF. So its frequency it is maintained. IF amplifier contains mutually coupled tuned amplifier with high gain. The characteristics of IF amplifier decides the uniform sensitivity and selectivity within the tuned range. So that's why it has a better selectivity and better sensitivity. The output of IF amplifier is detected and obtained to obtain the modulating signal, which is amplified by audio frequency power amplifier that drives the speaker to get the audio. In general, this is how the AM super heterodyne receiver that works. Now we are going to see block-wise distinction in detail. Let us study with RF amplifier. The output of an antenna is coupled to the RF amplifier by tunable circuit. Tunable circuit means it has to make use of series resonance circuit and also the parallel resonance circuit. As a series resonance circuit accepts the wanted frequency and parallel resonance circuit rejects the unwanted frequency. So that's why we can say it is connected to the RF amplifier by tunable circuit. Tunable circuit tunes the wanted frequency and rejects unwanted frequency. It has two tuned amplifier circuit that can amplify RF signal. Due to RF amplifier, image frequency is improved. The signal to noise ratio is also improved. That means it reduces the noise. It can reject the adjacent unwanted signal to improve selectivity. It avoids the radiation of the local oscillator frequency through the antenna. It can increase sensitivity, selectivity and the fidelity. Friends, this RF amplifier has a very wide bandwidth to accept all the signals which are going to lie within that particular bandwidth. So that signal is amplified by means of several stages which are going to be used in a RF amplifier. It may be common emitter amplifier, multi-stage amplifiers to achieve the required amount of gain. The fidelity, selectivity, sensitivity, all these characters are being decided by means of an RF amplifier. Now the output of RF amplifier is going to be act as a modulated signal frequency Fs. It is given to the mixer. Let us see mixer now. Mixer is called as a frequency converter or frequency changer with two input signals, one from the RF amplifier, that is Fs, and other from the local oscillator Fo. It is called as a frequency converter because it receives the two frequency. One the frequency local oscillator, second one is the signal frequency received by the antenna. It includes non-linear device like diode, and it has the ability to provide the several frequency when excited by the two input frequency. The output of mixer has four frequencies. One is Fo, that is oscillator frequency. Second one is Fs, that is the signal frequency received by the antenna. Next one is the sum of both frequency, that is Fo plus Fs. Next will be Fo minus Fs. It is known as intermediate frequency. But this is what we can call it as the concept of super heterodyne principle. But only Fo minus Fs, that is the intermediate frequency, is passed at IF amplifier. Sometimes Fsi is equal to Fo plus Fi manages to center frequency enters to mixer stage and mixed with the Fo so as to get the Fi. It is also amplified by the IF amplifier, resulting the interference. Thus, maybe two stations are going to be tuned simultaneously. The frequency Fsi is equal to Fs plus 2 times Fi is known as the image frequency. The output of mixer is tuned to IF amplifier. Two types of the mixers are generally used. One is a self-excited and second one is separately tuned, are the types of the mixers one can use in practice. Now we have to proceed to deal with the local oscillator. It is generally LC oscillator like Hartley, Colpitts or crystal oscillator due to their stable waveforms. Local oscillator frequency is always greater than that of signal frequency by IF frequency due to capacitor tuning. We have studied the Hartley oscillators, we have studied the Colpitts oscillator, we have studied the crystal oscillator in the last year. Now, by beating to frequency in the mixer, output of the mixer, it is given to the IF amplifier. IF amplifier is a fixed frequency amplifier with a function of rejecting unwanted frequencies. It has a steep cutoff frequency response. Means as it has a steep cutoff frequency response means it has to receive only that particular frequency, that is to which we can call as it is intermediate frequency. It makes use of B.Sc-III, FET or IC as a tuned amplifier for large IF. Selectivity and adjacent channel rejection are poor and has tracking problems. But for low IF, image frequency rejection becomes poor. Selectivity is sharp to cut off the sidebands and the frequency. Stability is high. By using these features, IF is selected. Now some standards IF used in practice. For AM super heterodyne receiver, which is generally going to operate within the frequency range of 540 Hz to 1600 Hz. Students, please remember these data. It is very important. The AM super heterodyne receiver operates within a frequency range of 540 Hz to 1600 Hz range, uses the intermediate frequency of in between 438 to 465 kHz. In between this, IF is used for AM super heterodyne receiver. Generally used IF for AM super heterodyne receiver is 455 kHz. Please remember. For television receiver, in VHF band having the frequency range 55 MHz to 223 MHz and UHF band 470 MHz to 940 MHz uses the IF of 36 MHz and 46 MHz respectively for television receiver. In VHF range means within this range IF is 36 MHz and in UHF range means within 470 to 940 MHz IF is 46 MHz. For satellite communication or for microwave radar communication, which is going to operate within the frequency range of 1 to 10 GHz, 1 GHz to 10 GHz, uses the IF of 30, 60 and 70 MHz respectively. That depends. For microwave radar operating frequency or for satellite communication, IF is 30, 60 and 70 MHz, which is going to operate within the range of 1 GHz to 10 GHz. If suppose there is a FM super heterodyne receiver, all of we are using FM stations, which is going to operate within the frequency range of 88 MHz to 108 MHz. This uses the intermediate frequency of 10.7 MHz. So this is IF for AM, amplitude modulated receiver, and this is 10.7 MHz is IF for FM receiver. So these are some standard data of operating frequency ranges and also the intermediate frequency range for which they are working. Now the output of IF amplifier, it is given to the AM detector or demodulator. A non-linear device like diode along with a parallel combination of resistance and capacitor with small capacitor and large resistance is used. It is known as the envelope detector. It detects the signal and recovers the original modulating signal from the modulated wave. That is, it produces the detected signal as a modulating signal Fs and feed to what? Feed to audio power amplifier. So now the signal is detected, only wanted information is obtained at the output, and that wanted modulating signal in the form of electrical wave, it is given to the audio power amplifier via a driver amplifier. Driver amplifier is a voltage amplifier that is used to drive the power amplifier. The power amplifier is complementary symmetry amplifier, or it is a push-pull power amplifier. Any one which is suitable that can be used. So that's what we can call it as, it is the audio power amplifier. The detected signal is amplified by push-pull power amplifier or complementary symmetry power amplifier, and its output is given to drive the speaker. Speaker converts so audio frequency electrical signal into its acoustic sound. Student friends, thus one can receive the tuned signal from the AM transmitter. It is processed and produces the wanted modulating signal from the modulated wave. This indicates how it recovers the original information from the modulated wave. So that's what we can call it as, it is a AM super heterodyne receiver. Next time we'll go for